Hello, Mr. Price here, and this is the fifth question of the June 2006 M2 paper, and this one is on centres of mass. Let's have a look. Okay, we have a uniform lamina in the shape of a square and an isosceles triangle on top, and we've given the sides known, and we want to find the centres of mass of X and Y of the lamina along AE and AB, i.e. using corner A as your datum position. Okay, don't waste any time doing this, just choose the datum position of where it wants it from. So, let's start off. We'll sketch our shape, and I'll try and make it relatively large so that it's easy to put numbers on here. Okay, and here's our datum position, corner A. Okay, I'm going to put on some values. So here's 18, 18, 15, 15. Okay, now we can see clearly we have a very nice line of symmetry down here. So X bar is very easy. It's this distance here, 9 centimeters. So X bar is 9 centimeters by symmetry. Okay, now for part Y, we're going to need the centres of mass of each individual lamina. So, by symmetry, again for the square, I can see that the centre of mass here is going to be the coordinates 9, 9. And it's important when doing this to put on the centres of coordinates of, the coordinates of the centres of mass for each shape. It makes it really easy. Okay, and then for the triangle, it's going to be 9 something. Okay. Now, remember, to find the centres of mass of a triangle, we need the coordinates of each of its vertices. Okay? So, this one is going to be 0, 9. And this one is 18, 9. And now we need this one. So, the x coordinate here is going to be 9, and we need the height of this triangle now to get this coordinate. So let's just draw a very quick diagram of this. So we have a length of 15, a height we don't know, and it's a radius of 9. Okay, so using Pythagoras, you should find that this is 12 centimeters. So that's our coordinate. Sorry, no it's not. So the height is 12, so 12 plus 9, that has a coordinate of 30. Okay. So we need the average of the y coordinates for the triangle. So y bar of the triangle is equal to 9 plus 9 plus 30 divided by 3. So the y coordinate for that is 22. So now we have the centres of mass of each lamina, 9, 9 and 9, 22. And it's a weighted mean, so we need to know the mass of each piece of these centres of mass. So effectively, what is the mass of this bit? What is the mass for this bit? We're not given a density, so we just use the area as its mass instead. So the area of the triangle is equal to 18, so the base multiplied by the height, 18 times 12 all over 2. So that is 108 centimetres squared, and the area of the square is 18 squared, and that is 324 centimetres squared. Okay, so now we can use our weighted mean to calculate the y-bar. So, we have this mass here, which is 18, at a position of 9. Sorry, 324, my mistake. 324, lots of 9. And the area of the triangle, 108. That's in a position of 22. Divided by the total mass, or total area, so 324 plus 108, which is 432. I'll do it properly actually, just so you can see where it's come from. So 108 plus 324. So after you calculate this, you should get a y value of 12.25 centimetres from our datum position. And that is part 1 done. 8 marks there. 7 marks there. Okay. For part 2, we're told the laminate is freely suspended from the point B, and we want to calculate the angle BD makes with the vertical. So, let's do a quick sketch of what this is going to look like. So, it's hanging from point B, so we're going to have the square that looks a little bit like this. And then our triangle on top. So here's where it's being suspended. And the centre of mass, which we know is somewhere around here, let's say, is going to be vertically below this point. Now, we already know the distance down to the base of the square. This is going to be 12.25. And we know the distance from this corner is 9 from symmetry, wasn't it? So that's 9. And we want this angle here. So if I now draw a little triangle of this, orientated where this side A is A. So there's this triangle side A, there's 9 centimetres. This is alpha. And so we know this is 12.25, so we can work out this distance here is, the whole thing is 18. So 18 minus 12.25 should give us 5.75. So that's 5.75. So that height is the same as that height. So A is 5.75 centimetres. We have 2 lengths, so we have enough information to work out the angle. So tan theta at tan alpha. Let's be correct with our units we've used here. So tan alpha is equal to the opposite over the adjacent. So using inverse tan, the angle is 32.6 degrees. And that is question 5 finished.